Good afternoon to all my dear students. In the last class, we discussed the formation of micelle. Okay. In this class, we will discuss the cleansing action of soap. Okay, by using this diagram, the cleansing action of soap. In this case, what happens? The cleansing action of soap is due to the formation of micelle around the oil droplets. Okay, first it formed the micelle around the oil droplets by soap ions. That micelle is formed by completely soap ions around the oil droplets. Okay, during this formation, part of stearate ion is in the oil droplets. Okay, you already know the stearate molecule formula. During this formation of what happens, the part of stearate ion is in the oil droplets. Okay, and the hydrophilic part means water loving. That part projects the outwards, since the polar groups can interact with water. Polar groups means that is in stearate ions. That groups can interact with water. The oil droplets, what it's surrounded? It is surrounded by the stearate ions. Okay, the stearate ions is surrounded by oil droplets. Okay, oil droplets is surrounded by stearate ions is now pulled into water. First it is pulled into water, okay, and removed from the dirty surfaces. Okay, and removed from the dirty surfaces. Then what happens? Thus the soaps helps in emulsification and washing the oil away. Emulsification means it is a process, okay, mixing up of liquids to form an emulsion. In emulsion, the dispersed phase and dispersion medium is liquid. So soaps helps in emulsification and washing the oil away. That oil droplets consist of what? That soap ions, that is nothing but stearate ions. Okay, there's some part of in that surface, some part of the stearate ions means hydrophilic ions, that first it pulls the water outwards. Okay, and it contains some dirty surfaces, and so the soaps forms an emulsification and washing oil away. The negatively charged shelf means one cover, it is layer, the negatively charged layer shelf around the globe, this negatively charged shelf around the globe, which prevents okay them from coming together and forming aggregates. Okay, so if it is not present, it will be aggregates. Okay, these globes will be aggregates. Because of presence of these negatively charged ions, it will prevent to forming the aggregation. This is about the cleansing action of soaps. Okay, in this case, what happens? The oil droplet means it consists of some dirty surfaces. Then what happens? That oil droplets surrounded by micelle, that micelle should be by soap ions. In that case, some hydrophilic part also there, and that outwards the water. Okay, and then outwards the water, so polar groups can interact with water. So the oil droplets surrounded by the stearate ions now pulled into water and removed from the dirty surfaces. This is about the cleansing action of soaps. Due to the presence of the shelf of negatively charged shelf, it prevents to form the aggregation. This is about cleansing action of soaps. By knowing this diagram, this is A, this is B, this is C. then what happens? The next part is the preparation of the best method suitable for preparation of metallic souls, means metal souls such as gold soul or silver soul. Okay, in this preparation it consists of Bredik's electric arc method. So it is Bredik's electric arc method. In this case, this vessel containing the water and alkali KOH, this vessel containing water and alkali KOH solution is taken in a vessel. This vessel should be kept, okay, because of this reason, by immersing on the surrounding vessel by ice water, because to maintain the cold or cooling. Then what happens? An electric arc struck between two silver electrodes or gold electrodes. In this condition, it consists of water and alkali potassium hydroxide solution. It should be maintained under cold process. Because of this reason, we have to immerse the surrounding ice water cold baths by immersing surrounding the vessel. And an electric arc struck between the two silver soul or gold soul. Okay, then what happens after struck between the electric arc? The small amount of, okay, first what happens? The spark will be coming. That spark causes the small amount of gold to vaporize. So then what happens? In this way, the atoms of metal in vaporized state of gold, the atoms of metals in vapor state aggregates to form colloidal solutions. So this method is useful for the preparation of metallic souls such as silver soul or gold soul. See, once again, in this it is consist of one vessel. That vessel should be containing water and alkali solutions like alkali KOH, and the ice is immersing on the sides of this vessel because it maintains the cold. And two electrodes. What is meant by electrode? Electrodes is nothing but electrode are the conductors to use to make electrical contact with some parts in a circuit. Okay, it is an instrument. It's an electrical contact. Okay, the conductor is used to make electrical contact. Okay, electrode means. Then what happens after electric struck? The spark will causes a small amount of gold is vaporized. The vaporized states, okay, the atoms of the metals of vaporized states aggregates to form colloidal solutions. So this is the best method in the formation of gold soul or silver soul. Next one is the preparation of colloids. How the colloids will be prepared in the laboratory. Okay, means chemical reactions involved in the preparation of some arsenic sulfide soul or sulfur soul or gold soul and iron soul. Okay, we have to prepare one by one. The first one is arsenious soul. Okay, are souls of arsenic sulfide. In this case, what happens? AS2O3, oxides of arsenium. Okay, AS2O3 plus H2S. Okay, H2S under double decomposition. What is mean by double decomposition? Okay, double decomposition means what? Okay, it is the two constant reactants interact. Double decomposition means the two constituent reactants interchanging the positive and negative ions and to form two new compounds. This is called as double decomposition. Okay, then what happens? Arsenium AS2, yes, arsenium sulfide soul is prepared. Okay, it is the water. You have to balance now. 3 times H2 is there, 3 H2, yes. Now remaining are balanced. Okay, so when AH2O3 is treated with H2S, then what happens under double decomposition? It forms as Na sulfide soul. And next one is by using SO2, sulfur dioxide, SO2, okay, SO2 plus again H2S, it is undergoing oxidation. You already know the meaning of oxidation, addition of oxygen or removal of electrons. Okay, what happens? Sulfur soul is prepared, H2O. Now we have to balance. Okay, sulfur 1 2 are there, we have to mention it is in 2, here hydrogen sulfur 2 are there, here 2 are there, so we have to balance by using 2H2O. So then what happens? We have to make it as 3. Okay, then again it is 2. So now it is balanced. And next one soul is, okay, AuCl3, Arium chloride. AuCl3 is treated with formaldehyde, HCHO. Okay, HCHO. On hydrolysis means addition of water. Addition of water, what happens? Okay, hydrolysis, it forms Arium soul, Au soul plus HCOOH plus 6HCl. Okay, now we have to balance it is. AuCl3 one is there, 3 hydrogens here, 1 hydrogen, 1 3 6 12 are there. So means addition, hydrolysis means addition of water, so 3H2O. AuCl3 plus 3 formaldehyde plus 3H means 3H water, addition of hydrolysis, addition of water, if we will get Arium soul. And next one is iron soul, ferric hydroxide soul. In this case we have to take FeCl3 plus H2O. Again it is hydrolysis, addition of water, hydrolysis, it forms FeOH thrice, ferric hydroxide soul plus HCl. You have to balance hydrogen as well as chlorine. It is 3H2O. Now it's balanced. Okay, this is about the preparation of colloids. The next concept is peptidization. They will ask for 2 marks question. What is mean by peptidization? Peptidization is nothing but it is a method of converting a freshly prepared precipitate into colloidal state by adding suitable electrolyte. So peptidization is nothing but it is a method of converting freshly prepared precipitate into colloidal state by adding suitable electrolyte. The added electrolyte is called peptizing agent. Peptidization means it is a method of converting a freshly prepared precipitate into colloidal state, colloidal solution range, colloidal state, okay, by adding a suitable electrolyte, is called depeptidation. The added electrolyte is called peptizing agent. peptidizing agent. This is about peptidization. Example for this one is, okay, when freshly prepared precipitate of ferric hydroxide, FeOH thrice, when freshly prepared precipitate of ferric hydroxide is treated with ferric chloride solution, FeCl3 solution, and stirred well, then what happens? It forms ferric hydroxide sol is formed. We discussed in this class, in this case only we discussed. Then what happens means a freshly precipitate FeOH thrice is treated with ferric chloride, is stirred well with adding, okay, stirred well, then what happens? The ferric hydroxide sol is formed. This is about peptidization and peptidizing agent and example for peptidization. The next one is the purification of colloids. Purification of colloids. Under this one we will discuss the dialysis and electrodialysis. This is about dialysis, this is about electrodialysis. We will discuss one by one what is meant by dialysis. Dialysis is nothing but, okay, dialysis is nothing but the process of removing the particles of true solution. Okay, the process of removing the particles of true solution from colloidal solution, from colloidal solution using one suitable membrane. Using one suitable membrane is called as dialysis. Means it's a process of removing of the particles of true solution, which contain, means true solution, it has containing the colloidal solution. We have to remove the true solution particles using one suitable membrane is called as dialysis. These membranes are called as dialyzers. This membrane is called as dialyzers. How it works, we will discuss the purification of colloids under dialysis. How it works? The impure colloid, okay, it is impure colloid. I will insert it containing, okay, it containing true solution. This is the impure colloid which containing true solution also. So it is taken inside a parchment, okay, it is a parchment base, okay, it is an parchment ball, okay, it is a parchment ball, okay, which is suspended, means bag, it is not ball, it is the impure colloidal particles is containing true solution particles is taken in a parchment bag, it is which suspended in a vessel, which containing water. This is inlet, this is outlet. Then what happens? This water kept continuously changing, means inlet and outlet continuously changing. Then what happens? The true solution particles inside the bag, true solution particles can diffuse, means move, can diffuse through the parchment membranes. Automatically in this bag containing true solution particles moves or diffuse, okay, through the parchment bag, to the parchment membranes. They moved all okay, move out and flow along with water. This water, when you pass the water inside and this true solutions diffuses through the parchment membrane, along with water it will be flow outside. So the process of removing of particles of true solutions from colloidal solution using one suitable membrane is called as dialysis. This is dialysis. The next one is this is electrodialysis. In electrodialysis, what happens? What is electrodialysis? Okay, it is the process of a true solution particles or ions, they can be separated. A true solution particles of ions or molecules can be separated from the colloidal solution by applying an electric current, by applying an electric field with the help of electrodes, okay, with the help of electrodes present in a colloidal solution. With the colloidal solution, means it is colloidal solution. That process we can call it as electrodialysis. Means it is also removing of the true solution particles from the colloidal solution under the influence of electric field with help of electrodes present in the colloidal solution. And this process we can call it as electrodialysis. How it works? See, in this case the process of dialysis is carried out by placing two electrodes in the water. This is water, Okay, an electric field is applied by using battery. An electric field is applied using battery. The negative ions present in the colloidal state means true solutions negative ions get attracted. Negative ions get attracted by the positive electrode, and the positive ions attracted by negative means cathode. Positive ions goes to negative electrode and negatively charged particles moves to anode. Okay, hence the ions came out. Hence this process came out and parchment bag is much faster. Okay, this is the, as compared to this one is much faster. Okay, means finally dialysis and electrodialysis is nothing but dialysis. It is dialysis. Okay, dialysis in what happens, the process of removing of the particles of true solution from colloidal solution using only suitable membrane. But in this case, by using electric field under two electrodes, we can remove the particles or ions of the true solution from the colloidal solution. This is about dialysis and electrodialysis.